Okay, so we're talking over quadratics, a little more about the lab, because that stuff's, it's not necessarily on the test. The lab isn't on the test, but quadratics is definitely on the test. We did have a day where we talked about quadratics pretty intensely. We talked about that b squared minus 4ac thing. We'll come back to that too. But to start with, the equation for this scenario. That's gravitational constant. This is how fast the kid threw it up. And this is the starting height. Would you continue, please? Plus 3t. Excellent. And then plus 1. That's all there is to it. You wrote the equation perfectly. Okay, now what's cool about an equation like this is then you can tell me where the ball is at any given time. What would be a logical time? Well, let's just figure out where the ball was 1 second after liftoff. 1 second after you threw the thing. That's time equals 1. I'm not sure where that mark is, but I'm just going to put a mark on the board here. Okay, where is it? Well, what did I just say? I just said t equals 1, right? So stick in a t equals 1. Use a calculator if you want to, because, 4.7 is going to be very nice to work with in your head. You could actually do it, but because I used 1. Figure out, we don't want to know the time. We already know the time. The time was 1. Figure out where it is after 1 second. All right, Mr. CP, tell me what to do. Okay, I just told you to put in what into what. Maybe we were just drifting. I'll come back to you on a different question. Okay. What do you think? KS? Nope, that's a different Keegan. Sorry, Keegan. I'll say Keegan. There's a lot of Keegans. Not in this room, but. Now, what'd you do though? What are we doing? Yeah, that's what I was trying to get the last time. Yes, I'm just putting in a 1 for t. And 1s are nice because when you multiply a negative 4.7 by 1, it's just what? Negative 4.7. Negative 4.7 and 3 makes negative 1.7. And then you add the 1. Was it down to just 0.7? So negative 0.7. All right. I want you to interpret that. What does that mean? Y equals negative 0.7. That means that they threw this ball in such a wimpy fashion that its height is, well, it went up and it went down and then it continued below the line, and the height would have been down here at 1 second. So 1 second wasn't here. 1 second was way over here, so that the ball would have theoretically been below 0. What does that mean? The ball was in the air less than 1 second. Do you get if you threw it really in a wimpy fashion that it might be only up in the air for 0.3, or no, that'd be really short. Maybe like half a second? All right. So that time gave us a weird answer. It's okay. You have to interpret things in the real world. Be able to go, okay, if the height is negative, that must mean that it went, well, then it's sort of like it landed in a parking lot that was made of mud and it just continued and kind of went below 0, so to speak. All right. So it seems kind of important to know what that spot is. That spot's called the X-Intercept, which is where what? Y equals 0. I go back to my original equation. I go into this original equation and put in y equals 0. That's this. That could have been h of t. That would have been a nice way to make it sound like height, sort of, But if I put 0 in there, 0 equals blah, 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 how would you be able to solve that? You could use your calculator. All right, you're going to use your calculator a lot. And on this next test, you get a calculator. So grab your graphic calculator. You cannot use Desmos, which is it's a pretty slick app on the iPads, but it's too difficult to keep you from being able to use the other features of the iPad, like all your notes, like You could be texting people in the middle of the test, like, and I know there's ways to lock you out of things, but that takes the teacher having to go to 32 computers and get you locked out, and then it's just not worth it. So someday it'll be really easy to like push a button up here and all your iPads will lock into only one app, and then that'll be awesome. I know we're getting there, but we're not there yet. I can't do it with Desmos specifically. So I know in the Apple app there's stuff that you can do, but I can't. If I do that, I also can spy on you all the time, and I'm not there yet. So I'm not ready to use that yet. So and again, I know it's coming, but it's not there for me yet. There are the first teachers are starting to use iPads for testing. How many of you have actually taken a test with an iPad? All right, so it's happening this year, and it's something I'm going to eventually figure out, but so far I haven't. All right, so for right now, use your regular calculator. The other thing is on the AP, not the AP, no, I shouldn't say it. On the ACT test, you're still going to have to only use these. It's going to be a long time before the ACT allows an iPad on a test, because even though it's coming, it probably is coming, because all the people who monitor the tests then have to be trained on how to lock a kid into an iPad app. You know what I mean? The people who monitor those tests are like just like a random gym teacher from here and an English teacher from there, and they don't know how to. A lot of schools don't even have iPads, and so as soon as they launch, that's going to be a long time from now before you can use them on your big tests. If you're using testing on a computer in the first place, I've heard that Desmos just got approved. It's one of the first calculators apps that ever has been approved for when you're taking a digital version of a test. They have a simulator of Desmos specifically. So that's one more reason we're probably going to see more and more of Desmos in your math classes. Okay, so back to, with the calculator, what would you do? I hope that you would put in this equation, y equals 0. Well, that's just the line that goes across it right here. I don't really need a line there. So then what am I doing with this equation? I put that equation into the calculator, and I'm figuring out where it hit, not where it hit the ground, when it hit the ground. I'm figuring out that spot right there. All right, I'm going to pause for a second while I tape that into my calculator. Okay, so I got my graph looking like this. Now, if you go to Zoom, I found a lot of kids come to me not knowing what their Zoom options are. I know you can read, but do you get that logically TI would probably set this up where their best type of Zoom is like number 1, 2, or 3? Most used Zooms? They're not going to like make their most used Zoom be like Zoom 7, right? So why do you think they put ZBox up there? Because Zoom Box is one of the most handy Zooms that there is. If you were arranging this list, wouldn't you want to put the most used ones at the top? All right, so you probably don't know how to use it though. Let me show you. If I go Zoom Box, it brings up a little plus sign. That didn't zoom anything. Well, it wants me to put a box around what I want to be zoomed. So I encourage you, if you haven't already learned this one, learn about ZBox, because if you want to see ZGraph, you should use ZBox. Dumb, but it sticks. There, I got it zoomed in on the area that I really care about, and it's going to look so much nicer. All right, do you see why at 1 second we had a negative value? Remember when we did that before? Because at 1 second is like right here, and yeah, it's down there. Okay, but what we're trying to find out now is where's that spot? Do you know how to do that? Second trace is an interesting option, but it's not, I don't think it's the best one. Trace is cool. Oh, you mean above trace. You mean like calc. That is what I was intending you to say. And that just I hit alpha by accident, sorry. Hold on. I need to hit second calculate. There we go. What am I trying to calculate here? Yes? You are right. You're right. But for right now, I'm going to stick with this second calculate thing. What is the thing I'm looking for? I could do a value, but that's not going to actually work here. It has to be if I knew what x was. I don't know what x is. I want to find the 0, right? Also known as the roots, also known as the x-intercepts. It'd be really nice if right there next to 0 it said comma x-intercepts, comma, you know what I mean? Because it'll do all of those things. Because zeros are the x-intercepts. You may think intersect, but it's not going to intersect unless you put a line at the axis. All right, so it's the 0. Now, this one's a little bit of a pain. It wants me to set up a left boundary. So I'm going to go, you should be following me on this, unless you want to do this, learn it all yourself on the test tomorrow, or Friday. Okay, so now I hit second calculate 0, and I'm now setting a left boundary. I move over to be just to the left of the 0 in question, and I hit enter. See how I put in a little dotted line there? Now yours, if you have an older operating system, might not put in a dotted line, but it'll put like a little caret symbol in, or something will appear up here. Okay, all right, there. And now I got to set the right bound. You go just past it. See how I went just past it, which also means under it, and then I hit enter, and I get my right boundary. Now it's going to tell me in between those two lines where it hit. And then I hit enter. Oh, it says 0 is at x equals 0.88. That means at 0.88 seconds, it hit the ground. All right, now I have another way in case you didn't like that. In case you didn't like that way of doing it, here's another way. Go back to y equals. Remember me saying graph both sides of the equation and then see where they cross? What's the other side of the equation here? Let's look back at the original equation. Do you remember that we set this equal to 0 over here? 0 equals all that? So then I could say y equals 0 is the other side of that equation. Now, watch what happens when I graph that. Since I have a color one, I can see a line going on top of the axis. If you don't have the color model, you can't see it there. But it's there if you typed in y equals 0. Everybody do that, please. If you haven't already, get a y equals 0 line in there. Now take a wild guess what I'm going to do. Graph both sides and then see where they intersect. I'm going to go second calculators right above trace. Second calculate, and then it gives me options, and this time I want intersect. I think this is easier because the questions that ask me about boundaries get everybody confused. If you go second calculate intersect, it asks me first curve. Am I on the first of my two things that are going to intersect? Yes, so I can hit enter. Now it's blinking on this other one saying second curve. Well, it happens to be a straight line, but they call it curve. I wish they just said line, but line, technically the word line means straight line. That's why they defaulted to curve. Anyway, second curve, yeah. I hit enter. Guess, it says. That means move really close to where it is and take your best guess. Well, I'm moving over, and I see how I can tell the answer is about 0.875 by kind of moving over to it. And then that's going to say, okay, well, I'll tell you the exact answer then. Intersection, 0.88. Get what just happened there? If you did get what just happened there, would you please find me the other intersection point, which is over there? Second calculate, first curve, second curve. Remember, you got to get really close to where they touch when it says guess. Give that a try. I'm going to pause while you do that. Okay, so here's me trying it again to find that other place where they intersect. Second calculate, intersect is number 5. I'm going to hit that. First curve, it says. Well, I can't really tell which curve I'm on. I'm going to arrow around until oh, I'm on that one. Good. Enter. Second curve. Yeah, I'm on the second curve. Now, this is important. It says guess. It'll just jump to the one I was just on if I don't tell it. I want to be over here. Okay, so I'm arrowing to the left here. Okay, so I'm arrowing to the left, and I'm going to keep going until I find where it says guess. I'm guessing where the answer is. It's about let me see what it says, 0.224-ish? I bet it's going to be, if the other one was 8.8, I'm just theorizing here. I don't know, I'm not even going to guess. I'll just find out. There it is. Negative 0.24. Now, do you get in the real world, that would mean time was at negative 0.24. Do you get how that's an extraneous answer? There is only one spot where the ball hit the ground, or actually, sorry, when the ball hit the ground, and it was right here. All right, lastly, what if you needed to find the highest the ball went? I know you could use trace, and you could get kind of close, but that would not actually give you the real answer. It'd be a good guess. So back to that thing above trace, second calculate. Which one of them do you think it is? Maximum. And once again, it's set up in a complicated way because we actually have a very simple curve here. Do you get a lot of graphs have like multiple high spots? So it can't just tell you the maximum automatically because it doesn't know where on the graph do you want the maximum. I mean, what if this thing was doing this? And then which maximum is supposed to give you? So it wants to know where on this curve do you want to know the maximum. So it asks for a left bound. I'm going to go left of my high spot. Does it matter that I'm really close? No. As long as I'm to the left of the high spot, I'm good. And hit enter. And now it says right boundary. I'm going to keep arrowing over until I'm to the right of the high spot. Am I to the right of it? Yes, so I hit enter. And now it says guess again. That means arrow over till you think you're about where you want, and it'll tell you exactly where it is. I can already see it's about 0.3. I'm going to hit enter, and I find out it's exactly 0.3 if I was going to round it. On your next test, you're going to be rounding to 3 decimal places, so I'm going to be using this 3 decimal place technique here. 0.319, and that's seconds. So the kid lets the ball go. Does the ball go up from their hand? Yes, it doesn't keep going up forever, right? It goes up until it hits a maximum time. The time at its maximum is 0.319. So that's about a third of a second. It's how high off the ground. That's the other thing that gives me. No, take a look. It tells you how high off the ground it is. That's this other thing. That's the actual height. So the time it reached its height was at a third of a second. The actual highest height it reached was this, 1.47. If I'm going to use 3 decimal places, 1.479 is where I should round to. Okay? All right, I'm going to give you a new parabola. And all we're going to do is change one thing. Do you agree that gravity's not going to change? Do you agree that the release point could possibly be a little higher than 1 meter? Okay, person launches it from up here, maybe it's like 1.5 meters or something. And so let's go back into our equation. I lied, I'm going to change 2 things. I'm going to make the release point be about 1.5 meters. And while we're on the way there, let's make the speed be a little different. 3 meters a second was pretty wimpy. Most kids can throw way harder than that. So let's make it like 8 meters per second. And then let's say that we launched at 1.5 seconds. That's the starting height was 1.5. And I want to go back to my graph. And whoa, my Z-box zoomed in too far. If you want to use zoom out, it's a great idea, but you need to know how to use it. If all you do is think when you get here and you hit enter that you've zoomed out, you'll be sorely disappointed because you haven't actually zoomed out, have you? So what do you have to do? It's asking, where do you want me to zoom out from? It's kind of a weird concept, but that little plus sign, I can move it anywhere I want. And I don't really care that much, so I'm just going to have it zoom out in that general area. And it pulls out, and now I can see, can I see everything that I need there? Yeah, I got the highest point, I got when the ball hits the ground. Do you agree that the ball's in the air longer now? And it reaches a higher height. Would you please find those 2 things? When did the ball hit the ground? What was the highest height it reached? Don't start listening to the headphones. I'm not that boring. I'll pause for a moment. Could you tell me, sir, how you did either one? I don't care. Pick one. Okay. The maximum. How'd you do the maximum? Second. Calculate. Press 3 for... That would be minimum. How about 4? Okay, 4. All right. Okay, I'm left of it, and then... Just so you know, it's a good idea to get kind of close at least, because especially on the one where you're doing this one versus that one, do you get if you're too close to the one, it'll just jump to that one. So you got to be at least kind of close to it. Okay, and then I hit enter. And then, did you get at 0.85, its height was 4.9 meters. That's about 1 second. I'm rounding a lot, but that's about 1 second later. It reached its maximum height of about 5 meters, rounding. Does that seem to pass the smell test? Do you think a kid can typically throw 15 feet high in the air? That seem reasonable? It's like basketball hoops 10 feet high. That seems pretty reasonable. All right. All right, and then the next part, Dice of Destiny. Who should I call on? Row 3, person 1. 1, 2, 3, person 1. That's you. Okay, walk me through it. I go second, calculate. Which one? The 0. And then? I am left of it right now. Right of it. Guess thing. Close enough. Jump to it. And what? Please interpret that. 1.87 means what? That's the time. And what's that y? It's really weird. Hint, -1. E to the -12 means move the decimal spot 12 spots to the left, which means 0.00000000000001. I know it's annoying that it can't say 0, but it's interpreting its own graph, and it can't tell if it's exactly 0, so it tells you that. I hope you get that decimal, that weird decimal. Just means that it thinks it's about 0. And it's point a whole bunch of zeros and then a 1. That's close enough to 0 for me. Okay. And at 1.873 seconds when the ball hit the ground. All right. Now let's do one where I have a kid who says they kept it in the air for 4 seconds. I want to see what that would do. If it was in the air for 4 seconds, do you get that that means their velocity must have been a lot higher? I want to make it from 8, I'm going to make it be like 16 meters per second. And I can't tell if the kid can throw that fast or not. But let's see how high the ball goes if I do throw it 16 meters per second. I just canceled my X out by accident. I got to insert. Insert is right here, second INS. It's right above delete. Insert an X. There we go. And hit graph. Once again, goes off my graph. Got to zoom out. Zoom. And that kept it in the air for 1, 2, 3.5 seconds. Let's see how high the ball went. Because if the kid's telling me that he threw it as high as a football field, that's going to be difficult for me to believe. You know what I mean? So let's see what the highest height is this ball actually goes. Zooming out. And I hit enter, and it'll actually zoom out. And now I go, second calculate how high was that thing. Second calculate the maximum. Left boundary, I'm to the left of it. Right boundary, I'm to the right of it. Guess, close enough. It says 15 meters, which is 45 feet. I can actually believe that a kid could throw at 45 feet. It's like 4 football, or it's like 4 basketball hoops high. I can believe that. Okay, so I guess I better believe the kid that he could keep it in the air for 4. This is 3.5 seconds in the air. I can tell because that spot right there is at about 3.5. But do you get how you could, you know, if, let's say this kid, I could keep it in the air for 9 seconds. Okay, well, that means you're throwing it like over the moon. I mean, if you can keep it in the air for 9 seconds, you could go back and tweak it until you figure out what their velocity is, and they'd have to be like a professional baseball player arm, which, you know, who knows? Okay, I guess that covers the main thing about parabolas, and this is also what we just talked about, is going to be what you use to help figure out the lab. Okay, on the lab, I just need one more measurement for you, and I'll get that to you either today or tomorrow. I can't tell based on how much time we have. I'll just have you walk past the ruler and see how high your head is, because you really said about your head zone, about your eyes. Okay, we'll get you that last measurement, and then you got everything you need. I just went through it right there. That's pretty much the lab, except you have different numbers, and you didn't know your velocity, but you knew your time when it hit the ground, so you knew that number. So you can plug some stuff into your equation. Writing this equation part will be critical too. Once you got your own personal equation written, you also know the time when it hit zero height. All right, so enough about that. I need to now teach you something called linear regression. Let me show you a basic idea. Do you get, if I had a bunch of dots that were doing that I could write an equation of a line through them? And if they're a little more random than that, let's say it's like that-ish, you still can do a linear regression. Basically, your calculator can figure out the line that fits the best. And once I got the line, it's cool because I can use that to make predictions. All right, so how do we do this? Basically, you got to enter data in your calculator. Let's say that this is at 1 second, and let's say that this is not a ball that's rising. Let's say that it is temperature that is rising steadily. Okay. Now, does temperature always follow a straight line pattern? No, but it could. Temperature could just steadily rise throughout the beginning of a day, for instance. At hour 1, at hour 2, at hour 3, at hour 4, and let's say that the temperature went from 67 degrees to 68 degrees to 69, but let's make it a little more random than that. So here's the data I want you to put into your calculator. Everybody get into stat mode. Get in stat mode. It's the button that's red on the screen right there. Stat mode. And we're going to edit that first list. You have lists, and you're going to hit edit. The first thing that comes up is edit. Hit enter. And now list 1. I got some stuff in my list 1. We're going to make that 1, 2, 3, 4. If there's more than that, you better hit delete to get rid of any other entries. Those are our X values, like our time. Next, go over into list 2, and we're going to make our temperature 67 for the first one. Hit enter. 68.2, just to add a little bit of like real world isn't always so clean. At hour 3 into the day, it's moved up to 70. And hour 4, we're going to go to 71.5. 67, 68.2, 70, and 71.5. All right, do you get I got some data that generally is in a straight line? That's why we call it linear regression. If we add quadratic data, you can actually do this with quadratic data too. All right, I'm going to go back out to stat. Hit the stat button. I know it feels weird because it makes things disappear, but it still knows what's in list 1 and list 2. I hit stat. Now, I need to calculate something, so I arrow to the right. I am calculating. Do I want one variable stats? No. Take a wild guess which one does what I've been saying. Number what? Number 4, linear regression. This is not quadratic data. This is a straight line, so it's linear regression. So I agree, number 4, lin reg. I'm going to hit number 4. Now this, at this moment, we have a divide of different calculators. Like some of you guys will have one thing, some of you will have something else. We want this to come from list 1 and list 2. And then we want to store that equation somewhere. Now, how many of you have a screen that looks kind of like this? Raise your hand if yours looks kind of like this. Raise your hand if yours doesn't look like this. All right. For U3, it's going to be, you want to type this in. You're going to want to type in L1, comma, L2, comma, and then you're going to say where to put it. So for everybody else that's got a screen like mine, L1, L2, and then store the regression equation on. It would be nice if we'd store it right here under our Y1. I'm going to clear this out. Everybody clear out the equation that you had in there. And we have room now to put that regression equation in there. So I'm going back to stat, calculate, linreg, and now I'm ready to put that thing on Y1. This is the only hard part here. I now have to find where the heck the calculator keeps Y1 in its brain. Okay? And I'm racking my brain for it right now myself. Just a second. It's under vars. I just can't remember where vars is. There it is. I'm now, everybody get down to where it says store regression equation, and it should be blinking right there. And everybody else that doesn't have to do it this way, you should still watch to see where Y1 is found. It's under vars. That stands for variables. And what kind of a var is this? It's a Y var. Is this a function, a parametric, a polar? We are going to learn those. You should be happy to know in this class we learned parametric and polar, but you don't know what they are yet, so it's probably a function. And, ooh, there it is, Y1. Hit enter. If you were not able to find Y1, I'm going to just remind you it was under vars, and it was a Y var, and it was a function. All right. Then I go down to calculate, and I hit enter. And behold, you have the equation, and not only do you have the equation for that line, it enters it right here on this. See how it's right there? It's already typed in for you. You don't have to like copy it over from the one spot to the other spot. It's pretty nice. Now what can we do from that? Think about this. This was our temperature going up in hours 1, 2, 3, and 4. We can now predict where the temperature will be at x equals 5. So if I go into my graph, if I graph this puppy, it's a nice straight line going up, but the problem is I can't see it because my y values, my temperatures, they're only like up to 10, right? So I'd have to zoom out a long ways. I'm going to move this so that my y max, which is right now only shows me up to 20. I was up in the 70s there. So let's make my y max be like 100. Then when I graph it, I can see my line. And now let's say I wanted, this is one more powerful thing under calculate. Second calculate a value. If I second calculate a value, that's where I tell it what I want x to be. Okay, see the one that's called value, number 1? Apparently it's used a lot. That's why it's the number 1 thing on the list. In value, it says, oh, look at that. It says x equals blank. What did I just say? I wanted to figure out the temperature when it was 5 hours later. That's x equals 5. And poop, it jumps through the spot on the thing, and it says it would be 73 degrees. Make sense? All right, if you understood that, please figure out what the temperature would be at hour 7. At hour 7. Go to second calculate a value, 7, enter, and there it is. Did you get 76? All right. Now I know some of you got lost along the way there, and some of you is because your operating system was different. For those that have the different operating system, when we went to stat, calculate, and we said linear regression right here, yours, you have to type in L1, comma, L2, comma, Y1. So where do you get those? They're all under L1 and L2 are actually on the screen here. There's L1. There's L2, the little blue thing above the 1 and the 2. And you need to put a comma, which is right here. L1, comma, L2, comma. Then you'll go look up that Y1 under vars. All right, now, this is critical. Tonight's homework is called linear regressions. You need to go in there. There are some example ones. I need you to find the first two linear regressions. And all I need you to get done tonight on tonight's homework is the first two linear regression problems. In tonight's homework, just do two linear regression problems. If you need to, go back and watch this video again to remember how this stuff worked. Linear regression is something that's covered on your next test, which is on Friday. But honestly, it's one of the easy things. That's all I got for you for today.